Starting from this session, I'm going to talk about data flow diagram, and this is the first part. First of all, in the system analysis phase, this phase can be divided into two steps. In the first step, system analyst would meet with end users to understand user requirements. And after this step, in step 2, system analyst would draw different types of diagrams, such as data flow diagrams and entity relationship diagrams, to describe their understandings of user requirements. And after that, system analysts would show those diagrams to end users, so that the end users could verify whether the system analyst's understandings are correct. So here, a data flow diagram would graphically describe the data flows between a system and its external environment, and also data flows among different internal components inside the system. And as I've said here, a data flow diagram actually is based on the information you have collected from users regarding user requirements. And finally, a data flow diagram. In a data flow diagram, our focus is on what the information a system needs, and also what the information a system generates. This actually is a typical data flow diagram. And this diagram shows the process in which a customer creates her user account. So as you can see here, so this system actually consists of 3 different processes. And initially, a user needs to select her username, usually her, let's say, email address, and also she needs to select her password. And this password usually is entered twice. For example, when you register your account, you need to enter your password, and below that, you need to re-enter your password. So that is why passwords are also provided to the system. So here we have a process which is called check username and passwords. So the name actually indicates its function. So basically, it would check username and passwords to see if they are valid. So if both of them are valid, then this system, which is here we have this process. So this process would generate this registration complete information to the user. On the other hand, if let's say either the username is invalid or password is invalid, then this system would generate an error message, and this error message would be sent to the user. So here, this actually is a typical data flow diagram. So in this kind of diagram, our focus is on, in this case, what the information is needed by a process, so that the process can function. For example, this process needs username and also passwords, and also it shows what information is generated by a process. Again, for example, for this process, it may generate let's say pass information, which means actually both username and passwords are valid, or either invalid username or invalid password information. In any data flow diagram, we have the following 4 types of elements, namely process, data flow, data store, external entity, which is also called external agent, or source, or sink. So we just look at them just one by one. We first look at the process. A process receives input data, and then based on certain calculations, it generates output data. For example, suppose you want to track your package at ups.com. So you provide your tracking number. And based on tracking number, this process would check the database and would output the corresponding shipping status. In the next example, this process would do the calculation based on the birth date of a person and also today's date. And then it would output the age of that person. In systems analysis and design, we treat the system and the process interchangeably. So that is, a system could be considered a process, and also a process is a system. So just like a system, a process could be divided into sub-processes. Here's an example. We have a process which is called handle order. The function of this process is to generate invoice based on order information. And here, this process is just like a black box. So we know its input as well as its output. But, from this diagram, we have no idea about its internal components and how its internal components communicate with each other. But if we really wanted to understand what are inside this box, then we can uncover this box and look inside. And then we have a more detailed view of this process. As you can see here, in this diagram, it shows that this process has two sub-processes, verify order and assemble order. So each sub-process is also a process and has its input and output. For example, verify order. This process looks at order information and decides whether the order could go to the next stage, which is assemble order. For this process, if we wanted to have more detailed information about it, then again we could uncover this black box, and then we have the following view. So that is, this verify order process has two sub-processes: check customer and check inventory. Check customer process checks who placed the order, and then it checks the person's credit history and decides whether that customer is able to make a payment. So if this customer's credit history is verified, and then this check inventory process would look at the products in this order, and then it would check if all of the products are in stock, that is, if all of the products are available for shipping. Then this verified order information is sent to the next stage, which is assemble order process. So here we have a very detailed view, but if we use a piece of paper to cover the two processes as well as their data link, then we are going to have something like this. That is, the whole process here has one input, which is order, and also one output, which is verified order. So which is exactly the same as this part of our diagram. In data flow diagram, we represent a process as a rounded rectangle. Inside the rectangle, we put down the name of the process. Here is a suggested naming convention. That is, the name of the process consists of two parts. The first part is a verb, and then the second part would indicate the data to be processed or to be generated. And here we have some examples, such as calculate the payment, verify order, and we have some more examples here. It is just a suggested naming convention because sometimes you may find it better to just put down the name of the system or subsystem you want to develop, just like this. The second element is called data flow. A data flow would indicate the input data or the output data. In data flow diagram, we use a line with arrow to indicate the direction of data flow. For example, here it means actually we have a sender. Right? This is the sender of the data, and this would be the receiver of the data. And also, we need to put down the name of the data. So this name could be either above the line, or below the line, or alongside the line. The third element is data store, which represents the data that the system needs to store. In data flow diagram, it is represented as a rectangle with the right side open. And inside the box, we put down the name of the data. And also optionally, we may give each data store an ID, right? So such as D1 or D2, so that each data store could be identified. The last element is called external entity. It is also called external agent. External entities, it is external entities out of the system we wanted to develop. Of course, in the external environment, there are so many entities. We only show external entities that either provide information to the system or receive information from the system. So that is why an external entity is also called a source or a sink, because it may be the data origin or the final destination of data. So here in data flow diagram, we use a rectangle or a shaded rectangle to represent an external entity. We have the following rules regarding a process in data flow diagram. That is, a process must have at least one input and at least one output. And also a process must be meaningful. And here we just look at the rules. First of all, a process must have at least one input and also at least one output, because the function of a process is to turn input into output. So here, as you can see here in this example, we have two processes. Each of them has one input and also one output. In this example, we have a process. Again, this process has one input and also one output. And here we have another process. So here, for this process, there's one input, that is the homework submitted by students. And then it has two outputs, that is the graded homework and also the score of the corresponding student. And in this process, we have two inputs. So here, we have pay rate, that is how many dollars for each hour. And then we have how many hours worked. So based on these two, then this process would calculate the gross payment. And then we have some examples of incorrect process. So in this process, as you can see, it has two outputs, but it doesn't have any input. So here, this process is called a miracle process. Because here, a process, its function is to turn input to output. So its output should be based on certain input. But here, this process doesn't have any input. It just automatically just generates output, so which is not meaningful. And then we have this example. So this example has two inputs, but it doesn't generate any output. So then this process is called a black hole process. So if a process doesn't generate any information, then this process is just useless. And then we have this example. So, at the first glance, this process has an input and also it has an output. However, if you take a closer look at this process, as you can see, this process is called calculate final grade. And here, this final grade is based on student address. And then its output is the student's grade. So which means, this student's grade is based on the student's address. So which means actually here, this process is not meaningful. Because actually a process should be based on certain business logic. So it does the calculation based on certain business rules. And the business rules themselves must be meaningful. And now we have a rule regarding data flow. So it's very simple because actually each data flow would connect the sender with the receiver, right? And here it says either the sender or the receiver must be a process. And we have some examples here. In the first example, we have actually two processes. The output of a process is the input of another process. So which means actually these two processes, they work sequentially. And we have another example. So in this example, we have communications between an external entity and a process. So here a customer may submit orders to this process. And then this process may give feedback information to this customer. That is, for example, out of stock notice. We have another example. In this example, this process communicates with data store. Actually, it communicates with two data stores. For the first data flow, it retrieves information regarding inventory level from this product's data store. On the other hand, it also inserts new order information into this order's data store. And then we have some examples of incorrect data flow. So in this example, as you can see, we have two external agents, customer and supplier. They both communicate with this process. So here, there's no problem with this connection, and also there's no problem with this connection. But as you can see, in this diagram, the two external agents communicate with each other directly. And here, this link is wrong because for this data link, the sender and also receiver are both external agents. And based on the rule, at least one of them must be a process. So of course, in reality, a customer and a supplier may communicate with each other directly. But this communication is out of the system we want to model. So in the data flow diagram, we shouldn't include this link. And then we have the second example. So in this example, as you can see, this external agent communicates directly with this data store. And again, this is not allowed. Because a data store is an internal component of the system we need to model. An external agent, which is out of the system, shouldn't be able to directly have access to our data store. So here, of course, in reality, you may say, in reality, a customer should be able to update her information, right? But here, this should go through a process. So here, the correct diagram should be like this. So, in this diagram, of course, just like here, this customer can communicate with a process called handle order. And also, if the customer wants to update her information, then this customer needs to communicate with a process, which is called update customer data process. And then this process would update a customer data store based on the customer's request. So here we have another example. So in this example, as you can see, we have a direct link between a data store and another data store. And again, this link is incorrect because data store cannot process themselves. And to correct this problem, we needed to add a process in between. And the story is just like this. So here we have some records stored in this orders data store. And then at the end of each day, we may need to generate daily reports. So that is, we may need to calculate, for example, total revenue, total cost for each day. Okay? So then we need a process which is called a generated report. So this process would retrieve information from this orders data store and then would produce aggregated information. That is, it may calculate total revenue and the total cost and then would generate a daily report. And the new daily report would be added to the daily reports data store. And then we have a rule regarding data store. And this rule is just like this, a data store must have at least one incoming data flow and at least one outgoing data flow. So which means a data store must be able to provide information to at least one process in our system. And also it should allow at least one process to insert data into it or update data in it. So which means actually here, because a data store is an internal component. So here in data flow diagram, we must see a communication, here as you can see, this process retrieves information from data store. So this data store provides information to a process. And also here, we must also see something like this. A process inserts data into a data store or updates data in this data store. So both directions should exist in data flow diagram. But here, for this rule, there's an exception. In very rare situation, we may see a data store and that data store may contain fixed data. And this kind of data are not updated by the system. For example, we may have a data store that stores tax rate table. And this tax rate table is provided by the government, the Internal Revenue Service government. And of course, here, no company can update, can modify, this kind of information. So here, for this kind of example, we only see one directional communication. That is, we have a process that retrieves information from the data store, but it is not able to update information in this data store. And then we have some examples. As you can see, in this example, we have a data store. So this data store provides information to a process. On the other hand, it also allows another process to update information in it. And again, here we have another example. This data store actually here, as you can see, it provides information to a process. And also we see two processes, they have the capability to update the information in this data store. So this actually is the first part of data flow diagram.